Hello, Fruitport High School AP Chemistry students. I hope you're having a good day today. Today I want to finish with another video. So if you're going in order, we had a class lesson on hybridizations of SP, sp2, and sp3 compounds. You watched a previous video on sp3d hybridization. And today we have this molecule, which is an sp3d2 hybridization. So you probably figured out the rhythm and what's going on. So let's just hop right to it. Okay. sp3d2 is the highest hybridization that we're going to study, and S and 3 P's and 2 D's give us a total of 6, which is why we're looking for a molecule that has 6 bonds around it. SF6 actually makes this structure, that Lewis structure, and you could take your time to practice making that. So this sheet of notes is really teaching us if you have 6 bonds and 0 lone pairs off of a central atom, what are the stats? What are the information? What is the name? And sp3d2 is the answer for the hybridization. And what shape is this? So some people said it looks like a kid's toy or something like that. Well, we actually call it octahedral, or we call it a square base bipyramid. And so this one here, if I were to get this kit, might show the square base bipyramid. I don't know if you can tell that we have a square equator, right, with the 4-sided pyramid pointing up and a 4-sided period pointing down, okay? Now, where does the octahedral 8 come from? Well, if you counted, there's actually 1, 2, 3, 4 triangles on the top half, and 1, 2, 3, 4 triangles, all the exact same size, octahedral. And this shape comes with a 90 degree. Every single bind angle is spread out as far as possible, 90 degrees. And these two would cancel out each other for polarity. These two would cancel each other out. And these two are also equally opposite directions in space and would cancel out. So it's not a polar molecule. You could draw it like this, or you could try to do the wedge and the dots to show 3D. Okay. Now, if we go on to our next little bit of notes, we're going to try a molecule that is sp3d2 with 5 bonds in 1 lone pair. Chlorine pentafluoride would be an example of that. And if you make the Lewis structure, you get 1, 2, 3, 4, 5, and a 6th thing around it. So, but 5 of them are bonds and 1's a lone pair. And so S, 3 P's, and 2 D's. Now, we've always had this debate, where will the lone electron substitute in? And we said in the last one, wherever there's the most space. But since they're all equally spaced, you could take any of these off. And this makes a square base pyramid. I don't know if you're looking from the top, can you see the pyramid bottom? And then you'll be 1, 2, 3, 4 sides arcing up to the top of the pyramid. This is the kinds of pyramids that the Great Pyramids in Egypt are made of, right? You have this from the top, the pyramid looking down, and I don't know if you guys can see the square base, right? The square base where the lone pairs would be underneath it. And you can see that we have this 4-sided pyramid. Again, holding these and manipulating them in class might be better than a video, but you get the idea. Bond angles are still 90 degree, and we would have some polarity potential because, well, these 2 atoms I'm holding on to are opposite of each other and would cancel out. And these 2 are spread out and canceling. But there's no bond on the opposite side of the one I'm holding here to neutralize and cancel out. So we have some polarity potential with this with this molecule. And after 12 of these, we're finally to our last one. Xenon tetrafluoride has this Lewis structure with 4 single bond fluorines and 2 lone pairs. And so we still have a total of 6 species. We got to make room for fluorine, lone pair, fluorine, fluorine, lone pair, fluorine. That's a total of 6, sp3d2. And when we go to make the shape for this one, the electron goes opposite of where the first one went. And so you'll get this, where the lone space for a lone pair is opposite from this side here. And this is a flat molecule, which we, in geometry for flat, we say planar. So we have a square planar molecule. If you like these kits, it kind of looks like this. We got the 4 here, and you can see a flat kind of molecule for planar. There's still 90 degrees, and because these are opposite and equal, these are opposite and equal, we would not have a polar situation. Okay, so when you're working on your homework, just make the Lewis structure, match it up to the notes, and you got this.